Okay? So, muna siya common sa physics. Okay? Kung siya balik-balikon guys. Okay? Kinematic motion. Okay? Meaning kasi kinematic. Okay? From the word kinematic. Okay? Kini meaning kinetic, right? Matic meaning automatic. So, when there's kinetic energy, it's automatic, okay, and then this gonna be motion, right? So we should remember these formulas, very basic formulas, guys. High school, right? Fourth year, okay, fourth year, third year, fourth year in physics, right? Okay, so we have velocity, distance over time, no, displacement over time, speed. Okay, let's put V as parang ganun siya because there are two speed, right? The scalar speed and the vector speed. Okay, so this is the vector speed meaning vector quantity. So this is gonna be magnitude plus direction. Okay, so ganito, north, south, east, west. Ganon. Then right, left, top, bottom, or upward or downward. So these are the direction. Or circular. Circular to the right or circular to the left. Ganon. Okay. This is, and then for the scalar speed, involves only the magnitude, small letter v, is equals to still d over time. This is the speed. Okay? And then guys, okay, are you listening mga kapatid? Okay. And then the distance guys is, for example, I have here, Sotero. Sotero is walking from point A to point B to point C to point D and to point F. So your distance covered, say for example, I'm just only walking without using the car first, right? Okay, so I cover the distance from point A to point B, distance 1. From point B to C, distance 2. From point C to D, distance 3. From point D to F, distance 4. So your total distance will be D1 plus D2 plus D3 plus D4. So this is your distance that you'll be able to substitute in your scalar velocity. Okay? Scalar, meaning addition of all the distances. So this is gonna be scalar velocity or the speed only is equals to the dt, total distance covered over the time. So this is scalar speed. So just put that in this way, speed. No need to put scalar, okay? So speed, but since we know speed is a scalar quantity, okay? Now we have the velocity is a vector quantity. Now we need to have, the d here is not the distance, it's the displacement. Now what's the difference between the displacement and the distance? For example, Sotero walked from point A to point B to point C to point D to point F. Now Sotero covers a total distance of distance A, distance B, distance C, distance F, or social distancing. Okay. Now in the displacement, it is not like that. Your displacement only will be final distance F minus the initial distance A. So meaning to say, in your displacement, you are only measuring the final distance and the initial distance without covering the in-between distances. So this is very, very important, how to differentiate between a velocity and the speed. Okay? Aside from knowing the fact that the velocity carries the direction. For example, when velocity, okay, if you try to be strict, that is not wind speed. That is really technically wind velocity. Because velocity involves magnitude and direction. Magnitude meaning the value, the figure. For example, 2 meters per second. That 2 is the magnitude. Okay? M is the unit. And your direction will be 2 meters per second in the east. 2 meters per second in the left, right, up, down, or in a in a roundabout. So that's direction. Okay, so you will never say speed because speed doesn't account the direction. This is very strict. This is a strict rule how to differentiate between speed and velocity because, ordinary citizens say that this is equal, especially if their course is not really related to science. Okay, but science graduates really know the difference between speed and the velocity. Though not all, it depends on the mental ability of the students or the graduates because we don't have the same IQ, right? So that's why we cannot say everybody knows the same thing with the other guy like that. So it depends on the students we are referring to. Okay, you get the point. But normally, under normal circumstances, most engineers or graduates related to science knows really the difference between the displacement and distance. Okay, you get the point for the purpose of discussion. But for normal saying that one, normal for ordinary citizen like not engineering or not engineer, they are not particular between the difference between speed and velocity. All they have to know is the same. Okay, as long as they are having the unit of meter per second, kilometer per hour, it doesn't matter at all, or miles per hour. But if you account the direction, you can no longer use the word speed because it's really wrong. It's really wrong science grammar. Okay, you get the point. So for example, if I have a tropical cyclone, you know what is a tropical cyclone? A tropical cyclone is a typhoon, another name of typhoon, meaning very strong wind movement. So a very strong wind movement carries a wind velocity, for example, 180 meter per hour southeast, hitting southern part of the continent Europe. Well, that is velocity. But if the reporter will never say the direction, it's just a speed. But anyhow, because they are journalists, they are not also concerned with the unit, the direction. Only engineers knows best about that, or the science-related courses, graduates, or the scientists. Okay? Very particular in the technical aspects of the unit, the direction, the magnitude, because most of us talaga, okay, love math, love numbers, as well as science coupled together. And so we are very, very particular for that. Okay? Not all, but generally. Okay? Ganon. So you know the difference. So the displacement here will be the final distance minus the initial distance. Mo na ibutang mo sa velocity. Do not interchange this one. This matters a lot in the computation, in the kinematic velocity and kinematic speed. Okay, with its corresponding acceleration. Okay, ganon. So that is velocity. Okay? I discussed a little bit this because the force doesn't involve too much velocity. That's why I added this topic. Okay? And then part of our problem solving will be involving motion mode siya, guys. When there is a force, there's a motion. Okay? And there's a distance covered. That's why we need to attach this particular topic. Okay. Now we have, after velocity and the distance, okay, we have also the acceleration. Acceleration is the rate of change of velocity, so that's going to be V over T. Okay? You get the point, mga palangga? It's going to be like that. Okay, if you have the velocity, then you have the acceleration. Okay? If you have also the speed, you have the acceleration. In this case, acceleration doesn't matter at all whether it is a vector quantity or a scalar quantity, whether it is a velocity or a speed. Because normally, when we say acceleration, you don't have to account the direction. That's really an acceleration. The rate is very important than the rate of change of the velocity. Okay. Any questions so far? Okay. So you need also to familiarize how to phrase that in a statement, so that you can create the definition. For example, acceleration. Define an acceleration, the rate of change of velocity. Because there's a time in the denominator that is a rate, R-A-T-E. Okay? Okay. How can you define the velocity also? Okay? Velocity is also the displacement over time. So you will say also, And the same, the rate of change of displacement is your velocity. So through words and statements, not the formula. Okay, so these examinations will always be like that. If that is not based on the formula or equations, then it is based on statements and words. Okay, and then multiple choice. A, B, C, D, ganon. Okay, so speed also, the small v is equals to the total distance or the distance over t. So how can you define this? Okay, speed is the rate of change of the total distance. Okay, so this is through rate definition. Rate. Why rate? Because there's a time in the denominator. Okay, just like computing an interest rate when you have a personal loan or a car loan, there's always reference of time, 3 months, 6 months, 1 year. That's why it's called a rate. R-A-T-E involves time, meaning dependent with time. Okay? R-A-T-E. Oh, ganon. Trust rating. Oh. Trust rating of Lenny Robredo. Meaning to say there's a particular period being discovered, let's say for 1 month, for 2 months, for 3 months. So that's the rate because it involves time or period. Okay? Muna siya definition sa rate. We should put that in our brain cells. Okay? What is RAT all about? Interest rate. Principal is also interest rate times in economics. Right? If you can still remember in basic in economics, principal times the interest rate times the effective rate interest times something like that. Okay? E is equals to IRT, right? The basic in economics, engineering in economics, something like that. Okay, and you have also the compounded interest, something like that, whatever, and the future accumulation after several years. Okay, so that's another topic, but what I'm emphasizing is the rate. Okay, like that. Chemical reactions also, that's rate law, there's a time in the denominator. Okay, first of all, d concentration of A over dt, meaning dependent in time. Okay, you get the point? Oh, ganon siya. Now, acceleration, velocity, then we need to compute now the kinematic velocity, kinematic distance, something like that. Okay, so we need to memorize this all the time, guys, ha? Okay? I don't have to prove na siya or to derive because it will take a longer time. Just go by yourself in the references, in the books, normally in physics, right? In your lower years, if you are graduates now, refer to the books, review, or you can refresh. But to the students, it's still fresh on their minds, right? Especially second year college students, or first year, like that, whatever, physics, right? Physics. Okay, so the kinematic velocity will be final velocity raised to the power 2 is equals to the initial velocity raised to the power 2. Ganun, di ba? Okay, plus 2AD. Okay, muna siya guys mga palangga. Okay? Oh, memory recall sa mga engineers. Okay, and graduates and professionals. Okay, this is gonna be the kinematic velocity. And how about the kinematic distance here, Sotero? It's gonna be distance is equals to initial velocity times the time plus 1/2 AT squared. Now take note what's the difference here. Okay, here in the distance there is a direct involvement of time. But in the kinematic viscosity, there's no direct involvement of time. But it's in the velocity that time will be incorporated because the formula of velocity, as I told you, okay, we have the displacement over time, blah, 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 so and so. But what I mean really the direct, you can see by your eyes immediately in the formula, that's what we mean by direct. But here it's not direct, right? Because you cannot see the t or time in this equation. Okay, meaning indirect. Okay, so if you try to break down the formula of velocity, that's the time you will see the time in the formula. Okay, so that's indirect. Okay, you get the point. Something like that. So you need to master this. Okay, because I think in the projectile topic, in throwing a ball like that, dropping a ball in the mountain or whatever. So you can also use this one. Okay? Dito po yung mga palangga kong hitad. Ano na siya. Now let's go to problem solving. Okay. Problem solving number 1, taken from mechanical engineer board examination. Okay. I choose mechanical because I'm boring. Pick up question from chemical engineers board exam. So to be different, this is from mechanical engineers board examination, 1982. Okay. Mga makaluma no, 1982. Okay. Because before, guys, we show the solution. Okay, not multiple choice. Because show your solution will really be competitive for me, rather than multiple choice. It's not through guessing, right? Right? Of course, you cannot get the answer if you'll never solve also, but it's totally different if you show your solution, right? Get the point. So, ang mga tapulan sa show your solution, nga. Okay, but ang mga tapulan sa multiple choice malipay because they will be able to sometimes guess or you know what I mean. Okay? Like that. Okay, muna ni siya mga palangga. Okay. So balik contact forces lang sa taha dito sa mga long range forces. Okay. Kapos sa itong mga long range forces, di ba? Nakakaloka. Okay. Okay, question number 1. A 12 kilogram, saan na siya a 12 kilogram cement bags. Cement daw. Bakit bags? Sige na lang. Cement bags is pulled. Okay, is pulled to the right. Okay, wow. Direction agad, diba? To the right by 350 Newton force. Charge. Okay, ganon. And then, that is, nakakaloka, that is agad 30 degrees above the horizontal. Diba? May napasin ka siya before, guys. If there's an angle of inclination, makulbaan na yun ko. Really? But it should not be that way pala talaga siya. Okay? It is in your mind that you label such things and you will be able to panic, something like that. Actually, don't label that one if there's something, you cannot understand. Just treat that as easy as it is so that you can solve it properly. Sometimes it's the mentality will matter. Even though it is easy to solve, then your mind says, it's difficult. Something like that, right? Perception and mentality matters a lot also in taking examination. Okay? You get the point? Because it's the mental will dictates you, not the heart. Okay? Nakakaloka. Heart talaga. Okay? Above horizontal. A constant fractional force. A constant fractional force. Okay. Actually, guys, I know the answer, but I did not solve yet. A constant fraction force. Okay. What's this? Of 120 Newton. Opposes. Or di ba opposes? Mean resists. Okay, opposes it. Okay. What is the net force? Nakakaloka. What is the net force? Net force. Just like saying, what is your net salary? Gross salary, total salary minus blah blah blah. Ganon. Okay? That is net. Okay? Net horizontal force. Right? Net horizontal force. Okay? Why stating that horizontal? Because there's also vertical. Okay? Acting on the backs. On the backs. And letter B, what's this? There are three, questions. Calculate the acceleration. Calculate the acceleration. Okay? Acceleration. And the letter C, we have what is the final speed? Okay? Meaning not concerned with the direction. What is the final speed? Because this is not velocity. What is the final speed at the backs? Okay. After it traveled, meaning it happens already. Past tense. It traveled a distance, okay, of 200 meters. Okay, ganon. So the first thing to do mga palangga is the one I taught you is to establish or to create a free body diagram or the FBD. If you try to solve forces in physics, FBD is the first step. Okay? Like that. Ganon. So sa mga given, mass 12 kilograms of the cement bags. Okay? And it's pulled to the right. Say, I will illustrate. So this is the cement bags. Okay? And then it has been pulled, meaning pulled, okay, not push. Okay, so here the direction will be pulled to the right, and the right is here, so like this. So if you pull an object or anything or a material going to the right, so that is covering the tension force. This is TF. Okay. Now, by a 350 Newton force, so the tension force is 350 Newton. Okay, 350 Newton. And that is 30 degrees above horizontal. So we need to scrutinize every terminology. Okay, horizontal. So we need to say, this is the horizontal. Say, I will put an imaginary line here. Ganon. And this is horizontal. Then we need to create a 30 degrees angle of inclination. So we need to erect an angle of inclination. Just estimate, okay, because this is only a schematic diagram or a sketch. Okay, 30 degrees, something like that, above the horizontal. Okay. A constant frictional force of 120 Newton opposes it. It's very self-explanatory that it resists your tension force because it opposes. Okay, this is an opposed. Okay, so what is your opposing force? This is the frictional force. It's gonna be going to the left because it's opposing the direction. Okay, going to the left. The arrow. So okay, this is your frictional force, which is the opposing force, 120 Newton, something like that. Okay, now what else? It's going to be like an only, right? Okay, question letter A. Calculate the net horizontal force. So net horizontal force, we will need to say summation because it is a net. Summation, you talk about summation, it changes from final to initial, like that. So like that, okay, changes. Okay, the difference, something like that. You put a capital like an E, what do you call this one? Like a capital epsilon. Okay, so F, epsilon, like that. Okay, like that, X. Okay, why X mga palangga? Because this occurs in X-axis. Okay, so F epsilon X is your net force. Then free body diagram na ta. So what goes here? Okay, we have the positive tension force. So positive TF. And then the other one minus the frictional force. Right? Now substitute values. TF is 350 Newton. Right? Newtons minus the frictional force 120. Why minus? Because it is negative. Okay? get the point? Then this will be your net horizontal force. But take note mga palangga, this is not purely a plane because this is an angle of inclination. So, in this angle of inclination, as I told you over and over again, this will establish a right triangle. If you try to elect this one, vertical, o ganon. Horizontal, ganon. Okay, if that is the case mga palangga, kumitag. Okay, so we have here the components of your force or components of your tension force. Let's say it's gonna be F. Okay, F. Okay, so you have the Fx component in the x-axis, and you have also the y component in your y-axis. So that is parallel with each other, then you can transfer all three Fy here with the same direction pointing upward. It's going to be Fy, something like that. So these are what we call components of your resultant force. Ganon. Now 30 degrees. Now again, what we will do, because we need to find the F. Okay, the F is your frictional force, something like that. Okay, not frictional, tensional force, tension force. Okay, because this is TF. Okay, like that. I think guys, in my board examination before, I am very curious on the designation of the symbols and the letters when I solve. Because admittedly, I solve so very fast. Okay? I solve very fast and very quick. That's why, I take for granted the letters, like that, too much erasures. Those are my formal, natural mistakes. Okay? I will admit that. Just like here, I always, consider this one. That's my usual error. Okay? You get the point? I'm telling the truth, right? Okay, now, so we have tension force. Okay, tension force here. So you will say TF. Ganon. How can you compute your TF? So it's gonna be, okay, considering your Fx, right? Guys, you are not considering the Fy because this is vertical. Okay? Vertical is not the concern here. This is not gravitational force. And you are not considering the vertical here because it's moving horizontal, right? So vertical force Fy is not considered here. Forget that one. And now we consider the Fx because this is horizontal position of the force with a corresponding velocity. So consider this one. So if you compute for this TF tension force or your resultant force, it's gonna be, this is the base, right? So if it's the base, it's going to be based on the Pythagoras theorem, angle of inclination of law of right triangle. This is going to be, if the base, then pasakit, naglibog ko gamay. Okay, I will recall. Give me 10 seconds. Okay, basa ha, okay. Maglibog pa ko pa rin sa tao ko sa tita, guys. Even before, maglibog ko. Okay, but I need to, extract well. Okay. It's gonna be the base, okay, which is Fx. So, I could say mga palangga, kumitag, okay, F, okay, cosine theta, gano'n, di ba? Cosine theta, which is your 30 degrees, is equal to Fx, your base, over the hypotenuse F. Hypotenuse F. Because your F here is not applied purely horizontal because there's an inclination. Though it's still considered also as an x-axis, but there's an inclination. Okay, so you need to say hypotenuse F. This one, the diagonal covered by the force. Okay, Fx. Okay, so now you compute with the TF, it's gonna be, or Fx was 30 degrees and Fx is equals to F cosine 30 degrees. Ganon. F cosine 30 degrees. You know mga palangga kumitag? Ganon siya. F cosine 30 degrees. Then you have to substitute that here. Okay, we're going to say 350, okay, cosine 30 degrees. Okay, you get the point. Since you have already the force, which is 350. right? And add only the cosine, okay, 30 degrees, okay, minus 120 Newton. So this is now your net force. Because we have already the force, 350. So we can solve our Fx. Why Fx? Because this is the tension force in horizontal axis. Okay? X-axis. You get the point? So wala mga horizontal, multiman ang desa, mga palangga kamitan. Okay. So where's my calculator, mga palangga? Okay, now can I solve that one? Okay, without calculator, di ba? It's very difficult, mga palangga kamitan. Okay, without the calculator. So cosine 30 degrees. Okay, nakakaloka. So cosine 30 degrees, nakakaloka. Okay. 30 cosine lang siya. Okay. Or let's say cosine 30. Syntax error kasi. Okay. Times 350. Guys, the technique is if there's a syntax error, you have to reverse only ha. Okay. For example, cosine 30, you will press the cosine, and 30, you feel the syntax error, then you reverse it. Okay? Like this, cosine 30. Oh, if there's an answer. If you say 30 cosine, it will be syntax error. And reverse that. Okay? So 0.866. Okay? So 350 times 0.866 mga kapatid minus 120 pila siya. Okay, so it's gonna be like times 250 is equals to minus 120. So you have a force of 183 Newton. Then review to make it short times 0.866 equals to minus 120 is equals to 183 Newton. Now analyze. Net force is 183.1. Okay? 183.1. Yes, this is your net force. Why so big? Because your net force will need to overcome your frictional force in order to move the object, or else it will never move it. It will never be moving. You get the point? See? Net force is 183.1 Newton is greater than with your frictional force, which is your opposing force. If it happens that your frictional force is higher, then your solution is wrong because the block will not move. Okay? How come it will not move when you are applying a 350 Newton, which is higher also than this frictional force? Things like this you need to back up during when you solve the problem. It's not enough to get the answer, analyze well if it is realistic when you get the answer. Okay, get the point mga palagana o dyan na pag-analyze. Charot. Okay, now yung 153.1. This is your net force mga palangga umitad. Okay, like that. So Fx, then 183 point, kasi na siya guys? 1 Newton. Okay. Papasok na po because I don't have enough space. Mga palangga akong hitad. Okay, mga palangga. Are you listening here, there, here and there, everywhere? Charot. Okay. What is space, guys? Charot. Papasok na ko. What is this? Okay, because we know it already, right? Okay. Then we can say, ano siya? A has been answered already. We go to letter B. Calculate the acceleration. Nakakaloka. Okay? Now, in the formula of acceleration, we have so many equations to be used. First, the ordinary acceleration, which is acceleration is equal to velocity over time. Okay. Second, the kinematic acceleration. Vf squared is equal to v squared plus 280. The a there is the acceleration. Third, the kinematic distance. Distance is equal to initial velocity times time plus 1/2 acceleration times t to the 2. 1/2 at squared. Ganon. Diba guys? Mga sinubuhatod din man. Bilhin mo guys ha? Mga palala kong hitad. Okay. Ganon. Now, another acceleration formula is through the second law of Isaac Newton. Okay, force is equal to the mass times acceleration. Of the four, which is applicable? Which is applicable? The direct one, the kinematic, or the Isaac acceleration computation. Okay? Which is really applicable. Una-una, ngayon ka. O diba? Now, okay, analyze ito one by one. Okay? We can never use directly the acceleration equals to velocity over time. Why? Because if that is the case, why we need the mass in our problem? There's a 12 kilograms, so the mass has no purpose at all. Okay, because we are trying to solve directly the acceleration without involving the mass, which is impossible. EKS. Okay, number 2. Kinematic viscosity katong final velocity squared, initial velocity squared, plus 2AD. Why we don't do that? Because in our problem, there's no velocity mentioned also yet. Okay? How can you solve for acceleration if there's no velocity yet? Here, the 2 velocity, the final and the initial yet. Okay? So that's EKS. Okay. C, kinematic distance. Again, there's no time involved here. Take on the problem. There's no time dependency. Okay, so you cannot use the acceleration in terms of time or with respect to time. So the closest of them all and the most appropriate is using the second law of Isaac Newton. Okay, which is the 3 laws of motion under second law, which is force is equals to mass times acceleration. Dito magpataka o gamit, ha? Okay. We should analyze. So force is equals to mass times acceleration. Why? Because in the problem we have the mass. There's a relevance of the mass. So that's what it means when we try to solve. There's a mass. So I can correlate this to the second law of Isaac Newton. I don't know what it tells of bad. Okay? Force is equal to mass times acceleration. And force also is very obvious. We have the force given. Newton, so perfect. So this is the perfect equation to be used. Okay. Now we have the force. We already compute, and the force here, guys, is no longer the frictional force or the opposing force and the tension force, but rather it is your net force to be used in computing the acceleration. You get the point? Okay? So, net force, which is equal to 183.1 is equal to the mass, which is given in the problem, 12 times acceleration in which you don't know. Ganon. So, 183.1 divided by 12. But take note also the mass have. Because sometimes also, the mass has another unit. And be careful also. Because this Newton, the unit of force will not be compatible with the gram. Will not be compatible with the pound. Something like that. Will not be compatible with another units. Okay? It is only kilogram. Okay? Because Newton is kilogram meter per second squared, so that your kilogram will be cancelled, and what will left is your acceleration, which is meter per second squared, like that. And you can never also substitute the pound because that is not, related. That's English. Okay, so that's gonna be like that. So acceleration is your kilogram. Okay. Yung din mo. Pero asal ito apply ang 9.81 meter per second squared. That is acceleration due to gravity. Standard. There's always 2 words attached. Acceleration due to gravity. If there's no such words like as due to gravity, that is the acceleration from the Isaac Newton or the acceleration from the one I discussed a while ago. The 3 also sources of acceleration computation. Okay? It depends on your analysis, but it happens only here that we need to use the second law of Isaac Newton. Okay. So, i-divide mo siya mga palamat ng data. Okay. So, 183.1 divided by 12 is equals to 15.25 is your acceleration. Okay? 15.25 meter per second squared. Okay. Like that. Nakaka-acceleration mo ni Ana. Now, question number C. Letter C, sorry. What is the final speed Nakakaloka. At the backs after it traveled a distance of 200 meters. Now, klaro kasi mga kinematic, right? Now, you will tend to use the d is equals to the initial velocity times time plus 1 half 80 squared. Never use that one because our problem doesn't involve time. It doesn't depend on the time. What time to finish in pushing or pulling this box to the 30 degrees inclined surface. Okay? So use the kinematic viscosity katong na final velocity. Okay? So final velocity squared is equal to initial velocity. Okay? Ganon. Plus 2AD raised to the power 2 on velocity. Okay? Ganon. Scrutinize and examine one by one the quantity and the terminology. Final velocity is the one we are asking for. Okay. Initial velocity. How can we get the initial velocity of this kind of problem? You remember that, guys, that this is starting from rest. There is a potential energy first of your block before you are raising that in the inclined 30 degrees surface. So there's a potential energy. Meaning to say, it is a motion at rest. Since it is a motion at rest, then automatically your initial velocity is 0. Okay? Because in the formula of potential energy, okay, it matters also the acceleration due to gravity. And when you account the acceleration due to gravity, it accounts also the velocity, something like that. You get the point? And the velocity is 0. Okay? Because it's not moving yet at the start. Okay? So, Vf squared is equal to 0 raised to the power 2 plus 2 acceleration na kuha na natin mga palangga, 15.25, and then the distance is 200 meters given. So you can solve for the final velocity. Okay. 0 raised to the power 2 is still 0. Anything, 0 raised to anything is always 0. For example, 0 raised to the power 1 million. Your answer are always 0. Okay? So it doesn't matter the exponent anymore if you try to raise the 0 to a certain numbers. Okay? So this is 0. Okay. Now, calculate that one. 2 times 15.25. Okay, times 2 times 200 is equals to, this is 6,103.33. 6,103.33. And this is meter, okay, meter second squared. Okay, meter squared second squared. Okay, why? Meter squared second squared. Because this is still square root. This is 2, okay, square root. In math, if there's an exponent of 2, then multiply that to 1/2. Both sides that the 2 will be cancelled. So it will become Vf raised to the power 1/2. Vf raised to the power 1/2 or anything raised to the power 1/2 is simply equal to square root. Again, anything that is raised to the power 1/2 is always square root. And then if I want to say also that Vf raised to the power 1/3, this is also cube root of Vf. And also Vf raised to the power 1/4, this is fourth root of Vf. So on and so forth until infinity. You got the point? Infinite. 1, 6, 1, 8, 1, 10, 1, 12, 1 trillion until infinity. The pattern or the rule will follow. Okay? You get the point? Something like that. So the square root of 6,133 is equal to, we have 78.12. So 78.12 meter per second. Take note guys mga talaga. Meter per second. I don't have to put the direction because the problem is asking final speed. No need to vary about the direction. Take note. If the problem will say, what is the final velocity at the box after you travel, then you have to put the distance. So this is obviously 78.12 to the right. Okay? That's the difference between the velocity and the speed. Okay? Or it will say only like that, 78.12 positive, 78.12. That's understood to be to the left. Okay? To the right, sorry. To the right, or the arrow going like this, arrow going like that, arrow going up, arrow going down. like that. Or 78.12 meter per second west. Diba? Okay. Kaya ano siya? East, west, north, south. Okay? But we are very, very lucky. The problem is only asking for the speed. Okay? No need to worry the direction where it goes. Okay, your answers will be 183.1 Newton. Acceleration is 15.25 meter per second squared. And the velocity is 60. So now I want to check the answers. Hi, ako makakaloka if these are really correct. Tadaan! Para makita ang hatag. Okay, let's say for the Mechanical Engineers Board Examination 1982. So net force is 100. Actually, guys, the answer is 182.99, but I have 183. It's very close, right? So only point something. And then acceleration, what's this? I have 15.85, but the answer is 15.23. It doesn't matter because it's only point something, right? And then final velocity, perfect, 78. Here, 78.118, and mine is 78.12. Okay, so it's nearly close. Okay, so it's correct. Okay, that's why I told you don't have to solve. You don't have to look how it is being solved when you study. Solve it first and then compare to the original problem so that it can measure your, your knowledge on a particular topic. Okay, because you are dependent, if that is the case. You should be independent so that you will learn. Okay? Again, in normal process of life, you should be independent in order for you to learn. Okay? If you are always dependent to anybody or to anything, then you will rely to them most of the times. If they are not with you, what will happen? So you cannot move, you cannot do such things because you are dependent entirely to them. The same in math. Okay? The same in calculations. You need to be independent to the sample problems. You don't need to solve that, but go to the another problems. Okay? If you want to solve the sample problems, then do not look how it is being solved. Okay, so that it will really measure your, IQ, math IQ, on how to solve that problem. Okay, get the point. Manisha, guys. Any questions so far? Okay, this is for contact force. Okay, thank you so much for watching this physics problem regarding net force, fractional force, tension force. Okay, with corresponding kinematic velocity, kinematic speed, kinematic distance, something like that. Okay, any questions so far, you can comment down below in the comment section. You can share and you can like and you can share to anybody else, of course. If you are not subscribing to my YouTube channel, then you can subscribe and you can click the notification bell for some news updates. And I am a singer, eternal voice, Junjun. I'm be coming back for another set of problems. Okay, thank you so much.